Hi, welcome to Building SaaS with Python and Django. My name's Matt Lehman, and on this stream we work on Django apps. I'm going to continue working on a Django app this evening, but before we do that, we're going to actually take a detour and do some Python exercises. I've been trying to do this for a couple streams, and I'm going to continue on that using this website, Exercism.org. It's got a bunch of exercises for teaching you how to learn a language, and we're going to walk through some Python stuff because I happen to know Python, and I can guide you through some things as I work through the problems, and we can kind of go through them together and learn a little Python on the way, and then dive into some software as a service stuff, which is the other theme of this stream. So I've got an exercise already downloaded and ready to go. It's this one entitled Blackjack. It's all about comparison and introducing to comparison operators like greater than, less than, all of that kind of stuff. But so it's sort of a gentle introduction to Python. We're pretty early in the track still. There are hundreds of problems, or maybe not hundreds, but there are over 100 problems to do on this Python track. And we're going to progressively get deeper and deeper into this, so the problems will get harder. Yeah, let's look at the problem that we've got in front of us and see if we can solve it. I'm going to start over here. You can see I've already downloaded this, and I ran the test in advance to prove that they are failing. And then I've got the files up here and ready to go. Hey, John, welcome. I'm sorry you're homesick. So glad you can join in, and hopefully this will be a nice relief to the end of your day. Ahmad, thank you for joining as well. Let's get going. Let's talk about what we're doing with this card or this card game, and see what they're asking us to do. And the nice part about Exercism is we've got some tests that we can run alongside of this, so we can prove to ourselves that this is right based on the tests that they have. Okay, so the first thing that they're asking us to do, and all of this is around the game of Blackjack and rules associated with Blackjack. If you're not familiar with Blackjack, sorry, I'm not going to go too deep into it. Hopefully you can get some idea based off these descriptions as we read. So we want to first start by calculating the value of a card. Now they're going to give us cards that are strings, I guess, as you can see here through the examples. So we're not working directly with numbers. We'll either be working with letters or a number to indicate the card's value in terms of either it's a numeric card or a face card, a suit card of Jack, Queen, or King. And so they say this. They say in Blackjack, it is up to each individual player if an ace is worth 1 or 11. More on that later. Face cards, J, Q, and K, are scored at 10 points, and any other card is worth its pip, numerical value. I did not know that this is what that was called, a pip. That's interesting. So we are going to define this value of card function that takes a parameter of card, and the function should return the numerical value of the passed in card string. Since an ace can take up multiple values, this function should fix the value of an ace at 1 for the time being. Okay. Later on, you will implement a function to determine if the value is an ace card. Okay, cool. I think I got this. Let's look at some code and see how this is going to go. We've got some instructions here and notes to remind us of what these things are. So my strategy here, I think, is going to be first look if it's one of the letter card, face cards. And then once we have that, we know that we can return a constant value from those, either 10 or 1, depending on the kind of card that it is. And then we've got 2 through 10. And those ones are a little bit, well, they're not harder, but they're just different, but we have to get the numeric value that's associated with that. So one way that we can do that in Python is to take the string and try and cast it or convert it into an integer. And so we'll do that as well. And I don't know if they're going to give us junk cards or not. We're going to take the naive approach that is going to assume that all of the values that they give us are valid face cards, or are valid cards. And that's important for a reason that I'll highlight in a minute. So let's start with this. Let's say if card, and then we're going to test against a list. And that is a way to check against a range of values out at once, rather than doing multiple if statements for each thing in a row. So if we can say if card is in a list of J, Q, or K, then we know that the return needs to be the value of 10, as they said in the rules, and as they say in the documentation string right here. Oh, you wrote Blackjack back in Fortran days. Oh, that's interesting, John. I've never used Fortran. I hear that it's good for numeric processing, I guess formula transformation, right? But I think I missed the Fortran boat for my education. I was the C++ days is when I was in school. So that's our basic one. So let's just do this for the moment. Let's say return 0 for the others, and let's see how our tests do. So we've got value of card is these bottom tests here. Let's try and run our tests right now and see how many of them go away. It looks like we have 8 different tests, and we probably have knocked out a few of them. 80 column cards. That's excellent. Ahmad, why do I not use VS Code or any other editor? This doesn't look good for eyesight? Oh, well, that's curious. Maybe 2 separate things there. I'll take those one at a time. As far as eyesight goes, I have tried dark themes in the past, if that's what you're getting at, of a light versus dark theme. My preference is just for light themes. I even gave on stream, I gave the dark theme with this editor about 6 months of really giving it a good college try, and I just decided it's not the style that appeals to me. So that's that. As for VS Code versus this editor right now that you're looking at is Vim. I've been using Vim since 2007, and I didn't stop. So I've learned a lot of shortcuts over the year that have made me super efficient with Vim. I think there are lots of good editors out there. Actually, I'm teaching my son to program. He's 10 years old, and he's learning on VS Code. So I have nothing against VS Code. It's just not the editor for me. After all of these years of doing it, I've found that I can extend my Vim editor to do all the things that I want to do, including a lot of the fancy stuff like language server protocols and everything like that. So I just don't use VS Code for those reasons. But I don't knock anybody who does like VS Code. In fact, I'm actually, I just turned another year older, and I got a new book. And that book, which I would strongly recommend to y'all if you're interested in this kind of thing, is called Crafting Interpreters. It's all about building computer languages, building programming languages, frankly, interpreted languages. And the author, Bob Nystrom, walks you through the whole process of doing everything to build a programming language. And he, in the book, builds 2 versions of the same language that he made up. One is written in Java, and the other one is in C. And for that project, I'm choosing to use VS Code because I don't have a Java environment, a Java IDE, and I don't feel like going to get Eclipse or IntelliJ or anything like that. So I got VS Code and then a Java plugin. So I too use VS Code. I just don't use it as my daily driver. So that explains that. Hopefully that gives you a clear enough explanation. All right, let's look at this test, and you can see when we reran things, we have some different values now. We've got our 0 case. So all of these things that are not looking like a jack or a queen or a king are passing through the bottom, and they're failing our test. Okay, but we're closer to having a test passing. So next, I think we will do another condition. And so now we don't need to check this one against a list because it's only a single value. So let's use a double equals and check it for the string of capital A. And that will be for our return, our ace value here. Okay, so run our test again, and we're down 1 more. All right. Ahmad, you're welcome. Hopefully that explanation was satisfactory for you, or at least gave clarity for why I do what I do. Finally, we have this card value that is meant to be the actual numeric value of the card. And so we're going to do the simple version here, which is to change this 0 that we've got at the bottom. And we're going to do this, where call int on the card. And what that's going to try and do is it will attempt to cast the string into an integer and see if it will work. Now, I think this is going to get our test to pass. Notice that test is passing. The problem with this approach in regular code is that this is making a really big assumption that card is always going to look like a valid card. If we had a value like you could assume, I don't know, I'll just put up here as a keyword argument. I'm not going to keep this, but just so you give you an idea. But a string I like to use often as to kind of a test of weird stuff is boom. So imagine that the string passed in was boom, like it's going to explode. And then if you got to this bottom here, and it's going to fall through those two conditions because they don't match, and it will try and do an int cast on that string of boom. And that doesn't make any sense for Python, so Python's going to raise an exception saying it can't do that. None of the values provided by this test are looking for that, so we don't run into that scenario. And frankly, I'm not going to worry about it since that's what the tests are. Just know that if you got farther along in this course, if you tried to do exercism, some later exercises will probably start looking for bad values and expect you to try and figure them out. But for the simplicity of looking at comparison stuff, we can keep it super easy and just assume that this is always going to be right. Okay, so that knocks out this value of card function. Let's move on to the next one. All right, so we need to determine which card has a higher value. So it says function having parameters card1 and card2. Oh, you're building a SaaS as well. B period. I'll just call you B for now. Welcome. I will get to the SaaS portion later. We're going to do a Python exercise here just as a kind of a warm up. And then we'll get into some actual Django code later, I promise. So we're looking at this next portion of the problem that says we have this higher card thing. And we've got card 1, card 2, and the same scoring. So I think to also tell us what to do about the ace. Both cards have... Now here's where it was weird. I read these directions before I started the stream. And it says if both cards have an equal value, return both, which I find it shows it. I guess they're showing off the power of Python and the dynamic flexibility of Python, but I wouldn't often recommend doing this because what's going to happen, and we actually see this below here, is sometimes you will get back a tuple of responses. This is what happens when you have a multi-value return with this comma. What Python is really doing under the covers is it's noticing that and it's packaging up into a tuple, which the whole tuple can be returned as a thing. And a tuple, if you're not familiar, is one of Python's data structures. It's like a list that you can't really modify the size of. So it's meant to be sort of a static thing. So you got this 2-element tuple as one type of return, and then this other type of return is just basic strings. The reason I would recommend not doing that is because any code that then calls this function has to then process, am I getting a tuple or am I getting a single string? It has to parse it differently, which is pretty strange. So I get what they're trying to do here, or I get what they're trying to show, but just as a note, maybe not the best thing to do for your own code. All right, so let's implement this though and figure out how to do it. And we want one of those three kinds of values. If card 1 is higher, card 2 is higher, or if they're equal. So let's get the, I guess maybe the easiest way to do this is get the values of each of the cards from, we can use our function above. This is nice, we get some code reuse now. And how do we want to write these variables? I don't think it really matters. We'll just call it card1 value, and the value of card 1. And then we can do another where we do it with 2. So we've got 2 variables now that are local. And so now we can do the comparison since we have the 2 local values to work with and return the right thing. So our first condition is if card 1 value is greater than card 2 value, then we can return card 1, right? And if that's not the case, if it's so that would be an elif. If the card 1 value is less than the card 2 value, then we want to return card 2. And then we can get out of the if-elif statement altogether. And now we know this is the case because we've already done the greater than and we've already done the less than. So the only possibility that's still left is when they're equal. And at that point, we want to return the pair like they said. So we've got those two things. All right. So if we did this right, all of, where is it? All of these higher card tests should just disappear. And they did. We got them all right. Cool. So this is a practice that I do as well. Like when I'm doing code development, sometimes I sometimes will write a test first. This is, in this sense, it's kind of, I wouldn't call this test-driven design because somebody else wrote the test a long time for you, but it's similar to a test-driven design pattern where you write a failing test to prove the state you're trying to get to, and then you write the code that passes the test to prove to yourself that the code is working as you believe it to be working. So we're kind of following that pattern here. All right, so we've got 2 of these done. Now, another way we could have done this, there's nothing that says that we need local variables here. We could have, as well, in each one of these, called value of card multiple times, and that would only be 2 additional calls to these functions, which is probably okay. But for clarity, I thought it would just be better to just pull out the values. Okay, let's move on to the next function here. So we've got calculate the value of an ace. So they said earlier that an ace can be worth 1 or 11, depending on some other factors. Players in Blackjack try to get as close to as possible to a score of 21 without going over. So you can be less than 21 or equal to it. That's a legitimate value too. So we want to have this define. We want to define the value of ace with parameters of card 1 and card 2 again, okay, which are a pair of already played, which are a pair of cards already in the hand before getting an ace card. Okay, so this is more blackjack knowledge. Like you keep getting multiple cards dealt to you sometimes. So you can be in a state where you have 2 cards in your hand. Your function will have to decide if the upcoming ace will be a 1 or 11 and return that value. All right. So remember, the value of your hand with the ace needs to be as high as possible without going over 21. All right, so if they give us, if we already have a 6 and a king card in our hand, that would be 16 points, right? So that's why they're returning a value of 1 here, because if we got an 11, that would be 27, which is over 21, not allowed. Here we've got 7 and 3, which is 10. And an ace in that scenario would make a 21 value. All right. So it says, hint, if we already have an ace in hand, then its value would be 11. All right, so there's probably a test for that. Interesting. Okay. Does that make sense? Because if you had an ace in your hand, I'm not sure that that's 100% true. Because you could have 2 aces. Well, let me think. I'm not sure if I agree with this 100%. Like, it's probably wise to always think of it as 11, but I could see this happening in a scenario where you could view an ace as a lower value card if the second ace is going to make you go over. Like, if you have an ace as 11, and a 6 card, and you get another ace, would you want to view that as a 1? I guess you'd have to, because otherwise you go over. All right, so maybe that's what they're trying to say. Is like, in all the scenarios that play out, you have to think of the aces as an 11. Okay, so let's get our card values. So the first thing we want to do is the same stuff. We're going to be dealing with the values, and we want to look at the totals too. So let's go ahead and bring those down here so that we can recycle them for our value of ace. And so we want to look at the sum of those two. And we'll call it your hand value, because that's the cards you have in your hand, which is the sum of these things. So that's card 1 value plus card 2 value. All right. So the basic rules, there's going to be some edge cases to this, which is why I'm kind of taking it slow. We're going to probably put out a version that's going to work for a lot of the values and then fail for the ace and fail for some other stuff that we'll have to adjust. So we know that if our hand value is anything of 10 or less, then we want to treat we want to think that the value of the ace is a 1. So let's do that. Or sorry, that the value of an ace is 11. So let's start with that assumption. So if hand value is less than or equal to 10, then we want to assume that the value is an 11. Otherwise, we'll return a 1, because otherwise, like, this is over that, and it'd be too much and make you go over 21. Let's try that and see what that knocks out. I suspect that it's going to knock out some stuff, but there's still going to be stuff, like you see these pairs that have an ace in there. That's not going to work right, because if you remember, our value of card function from the first step returned ace as a 1. So that's going to be off. So let's run the test and see what happens. I suspect we'll see all but maybe 2 of these drop out. Yep. And the 2 cards with an ace in them. And look, even so they're crafty. They're thinking about this, that the card, you got to compare and look at each card too. You can't just leave one or the other. So they are considering both cards. Either card could be an ace. So the way that we're going to handle this is, if one of these cards is a 1, then that means it must have been an ace, because, well, is that right? Yeah, because in a typical deck of cards, you have 2 through 10. So ace kind of stands in as the 1. So if any of the values are a 1, then we're going to go ahead and add 10 to it and assume that it's the 11 already. So let's say if card 1 value is equal to 1, then card 1 value, I guess we don't need to add 10 to it. Let's just go ahead and set it to 11. Why not? Can't you just test again for a value of 10 or lower? Tell me more, John. What you're probably seeing something that I'm not. And if I'm not, so I'll do this and we'll get the test to pass, and then you can school me on, like, what am I doing wrong here? Because I could be doing this in a naive way. All right, so I did get the test to pass. Whoops, nope, I didn't. What's the problem? Card, needs to go after that. All right, so we have that test passing. I'm happy to figure out what you're talking, like, let me ponder what you're saying there. Can't you test again for a value of 10 or lower? At what point, maybe is the question I have for you, John, when are you thinking about that? I'm going to move on, but if you have a clarifying comment there that will make that clearer, then I will happily revisit. All right, let's look at the 4 on this. I think there are 6 of these parts, so we're halfway through. So now we're looking for a blackjack, basically, and this is returning a Boolean, as you can see from these results down here. So if the first 2 cards a player is dealt are an ace or a 10 card, given a score of 21 and 2 cards, the hand is considered a natural or blackjack. Okay, apparently those are synonyms. I didn't know this either. Learning something new about blackjack. Pips, what was it? Pips and blackjacks and naturals, and okay, cool. So we've got a function that is looking at the card 1 and card 2 pairs, and they're determining if the 2 card hand is a blackjack. All right. So the score calculation can be done in many ways, but if possible, we'd like you to check if there is an ace and a 10 card in the hand or at a certain position, as opposed to summing the hand values. All right, so let's flip some of this logic. Like earlier we had, like back at the, looking at the, trying to calculate a number here. We had the card and we were looking at for a jack, queen, or king. I think we could determine if one of these things was an ace. And actually we might want to do this for, come back and refactor this value of ace thing based on this thought. Yeah, it may not work because we might need to know both. But we know that if given card 1, card 2, one of them must be an ace for this to be worth pursuing further. So if we do this, if we say if A is in the list of card 1 or card 2, so we're effectively asking Python, are either of you an A? Then that's when we want to proceed. But if we don't, actually I want to invert this logic. So if A is not in these, then we know right away that it's not a blackjack. Return false in that scenario. So let's run PyTest, and I think we knocked out some of the tests. I didn't actually see how many there were beforehand. My fault. Let's scroll up for a minute. So there are a bunch of tests for is blackjack, and I think we knocked out anything like 10 not. Whoops. Oh my goodness gracious. We knocked out anything like 10-9, 4-7, 9-2, all of those things immediately you're out. And queen king. So what we should be left with is the things that look like they have aces still left in them, which here we are. We've got ace king, 10 ace, ace ace. Interesting. So what do we need here at this point? I think we need a 10, and it could be a numeric 10, or it could be a face card, jack, queen, king. So I think what I want to do, oh my goodness, lost my editor. Where'd it go? I think what I want to do is, if we got this far, we have at least 11 points. So now if we get the 2 card values like that, and then we can do a check on if 10 is in this list, is in another list. So let's do it like this. Return, we're going to write it like 10 in list of card 1 value or card 2 value. I'm not liking how this is looking. We'll come back to that in a second, but hopefully that was clear on what that did. Like we've got 11 guaranteed by this step. If we don't, we return false, and then we're trying to just look for a 10. Now, I think in this scenario, since we only have to call value of card 1 time each, I think what I want to do is kind of inline these function calls to get something more like this. And it's going to tighten things up a little bit. I don't always like to do this, but in this case, I think it will lead to a cleaner, simpler result. Okay, I think that should work. Yep, cool. So that one's down to a fairly simplistic 3-line function. Let's look at the can split pairs part. Splitting pairs. If the player's first 2 cards are of the same value, such as 2 6s or a queen and king, so not the same card, but the same value of a card, a player may choose to treat them as separate hands. This is known as splitting pairs. So define, sorry, so I think this one might be the easiest one of all, because really we're just doing a comparison of the two values. So I think it's going to be return value of card 1, if, oh my goodness, sometimes I use a different keyboard where I'm in the basement of my home, and I don't always get it's a Microsoft Sculpt. And the positioning of that top row is slightly different from my other keyboards in my house, so I will type the parentheses wrong sometimes. So value of card and card 2, that should knock out that whole test, or that whole function. Whoa. Card, oops. I did not type card 1. All right, very good. We're down to one last thing. Now, let's look at this one last thing. Can double down. What is it saying? When the original 2 cards dealt total 9, 10, or 11 points, a player can place an additional bet equal to their original bet. Okay, this is another one where I don't think there's much to this one. In fact, I'm going to take this same line. I'm going to paste it here. We'll change the comparison operator to a plus. So essentially, I think what it's saying is we want the summation of value of cards to be in the range of 9 through 11. That sounds like the conditions for this. Cool part about Python here is you can do multiple inequality comparisons in a chain. So that leads to this this nice syntax of saying 9 less than or equal to, and then the sum in the middle, which is then less than or equal to 11. Now this is a pretty, I think, a fairly unique thing that I've seen in Python. I've not noticed a lot of other languages that kind of do this. In a lot of other languages, you'd actually have to do something like, I'm just going to write it here, like if you could do, same left-hand side, value of card 1, but then you'd have to do something either in a C-like language, or so it'll either be ampersand to talk about logical and, or it might be the word and, but something like that. But you can't chain them together. So hopefully you can see the distinction there. I think this should be correct. Yeah, look at that. Okay, let's look back. So of all these functions, I think this feels like the tightest and cleanest version of this. This is when the ones that are one-liners, and this is Blackjack, they feel nice and short, and what I want. The ones that I'm not crazy about are, well, I guess also value of card. I don't think we can make this any shorter. I mean, I could do this, but then I have black that wants to reformat it, so I like using black for my code formatting. This felt like probably the best solution for this. The only way that we could really make that shorter is by having value of card be kind of inlined on each of the if statements, but then you call the function one more time. So that could be a little shorter at the cost of some computation. But it's this one that something just doesn't feel quite right to me. I'm wondering if there's a simpler way. But I think I'm going to punt on it, because I feel like we've spent a good 30 minutes on the problem, and we probably have given a good chunk of time to looking at comparison and thinking about some Python here. Hopefully you were able to glean something from the way I approach the problems and see through it, see what I've done there. So what I'm going to do is we'll submit the exercise to Exercism to have the solution be checked and get credit for the future stuff. And then what we can do after that, you can check for an ace in the hand first. Which one? Are you talking about this value of ace one? Like, are you talking about like maybe like I did with the is blackjack? Let me think on what you said there. So if we know one of the cards is an ace, then we can, they were saying assume, is this the one where they said assume it's already an ace? Okay, G, thank you very much for that contribution. Really appreciate that. We already have an ace in the hand, then its value would be 11. How can we use that to our advantage is what I'm trying to figure out. Like, so this would say, if the hand has an ace, then the other one must be a 1? Why couldn't the other card be a 2 or a 3? You're kind of losing my, you might be onto something and I'm just not seeing it, John. That's totally possible. I found that doing these kind of problems is getting your brain engaged while trying to speak it out loud and talk to y'all is tricky sometimes. So, all right, let's put it down there. Here's what I'll do. Let's try and re-implement this function. Give it a second chance based on something like this. So now we can know definitively if there's an ace in here. Does that help us? Because the total, because we still don't know which one is the ace. So what I would need to do is find of the list. If we make a list, we could determine and could determine which one was the ace quickly. Then we could look at the value of the other card, but I don't know if that's going to, there's a lot of other card combinations that could have. So I'm just not sure if it's like just special casing something that is going to get us there. All right, how about this? Let's do a submission and let's look at some community solutions. So there's a cool part about Exercism. Exercism has this a set of community solutions. So every time we submit a solution, you can make your solutions public to other people, and it allows other people who have done it to come back and look at how they did it. And I'm hoping that we'll discover, John's probably seeing something that I'm just not, my brain is not clicking on right now, and maybe we'll see that in some of the other solutions that are there. A check for 2 aces in the hand would be a problem too. Yeah, I think you're right. Like, what happens if there are 2? That's a good point. So we do exercism, submit, and then we've got our solution file, which is this blackjack.py, and that'll go up. I guess yeah, okay, good. I did uncomment the correct version and save it before I submit it. So let's go to the top of the problem. And once you've submitted, you have these options that are kind of blanked out until you start clicking through, but I know I've submitted, so now I have an iteration here. Static analysis is telling us we did something goofy. Yep, I did this last time too. So one of our solutions uses the elif, but it has a return, so that doesn't make any, this elif would never happen. So if it's trying to say, like, if you go inside of this, doesn't matter. So we should be able to get rid of that, I think is what it's saying. Line 37, yeah. All right, cool. That would fix that. Let's go ahead and resubmit. Get a clean solution. No warnings. Thanks, Pylint. And this is just an integration with this Pylint tool, which is kind of if you've used Flake 8, Pylint's like a more persnickety Flake 8. It's got more opinions on the ways to do code, and in this case, I think it's a good one. They might. It's an easy thing to tune as well. So you can tell it, hey, don't be so noisy about that. And you can use it in big projects. All right, so we've got our solution. That's all done. Let's go look at some community solutions, check a couple of those out, and then we'll move on to the SaaS stuff after that. Oh, look at that. I'm already seeing stuff that I like. So let's check out this version. It has a bunch of comments. I like the ones that have quite a few stars, or I can catch something in the preview that looks interesting. We don't need to review 1,000 of these though. Let's just take 4. That should probably be enough. See what they got to say. Oh boy, we're already using operator and EQ. Interesting. So first thing to note is they're using type hinting here. There's no requirement to use that. I think they're just showing. What do? They modified. Oh wow. So our solution, they have modified the function signature. So they added a new parameter onto that. And the way they got away with that is because Python, as long as you have it as a default value, that's not going to break on the exercism size. That's actually really kind of a clever way to. I guess it's not really bending the rules. I hadn't thought of that. So that I'm guessing they used value of card later on for other purposes, which we will see. All right, looking in here though, what we did was we made a list with 3 strings in it, but it's saying card is a string. That's what they passed to us. So you can check for a string by itself can act as a thing to iterate against. So ours is kind of a frankly, more memory using way of doing the same thing because it's iterating over 3 individual characters. And theirs is saying you can iterate over a single string character by character. There's a very subtle difference there, but it's probably fewer memory allocations if we really got down to it, because it wouldn't be creating a list object. It wouldn't be allocating 3 separate strings. It's just 1 string. So that's clever. I like that. There's one thing we can learn there. Otherwise, the thing is the same, although they're using this ace value here. So maybe they have something more up their sleeve later on. So we've got, so they did the thing that I said you could do that I didn't do, is you could inline these and call them instead of assigning the values. So pretty much exactly my solution, except they're not using temporary variables. Value of ace. Value of card. All right, so they changed the signature. So it's not just card 1 and card 2. And this is doable because they're using the list. What's the technical definition for this? Sometimes you hear this called like a splat operator. The idea is like it's essentially a globbing or a grouping of all of the list variables, and it's using the star. If it was using star, that would be for keyword arguments. So it's specifically saying all of the positional arguments are now being grouped together into a single variable, which then they're able to iterate over like so. And then they're using their modified value of card thing, assuming that the ace is 11. And so there's some cleverness going on here. I like that. They found a more clever solution to get around what I did. And the way they got past that is essentially they seeded the fact that we don't want this to be 1. There's the cleverness. By forcing it to be 11, which by doing that, they get to avoid this comparison, because up in the definition of value of card, this can be whatever that value, that keyword argument was. It's a little bit of like indirection to avoid some comparison here and some changing of assignment. So good on them. Otherwise, though, it is the same. I mean, I used less than or equal to 10, returning 11, and they're checking against their sum greater than or equal to 11. Oh, I wonder if it fails on a boundary condition. Well, they passed the test. That boundary condition seems a little weird to me, but maybe there's something there. Otherwise, clever job. Good on them. They did is Blackjack, value of card, ace value of that. So same kind of thing, equal to 21. I did, ours is different because we're looking for that A, and then we're just saying if either of those is a 10. So mine was a different approach. Can split pair, probably I don't know why they did I've seen this before, and maybe somebody has some reason for this, but using the EQ operator on the list of cards. So, all right, how do I unpack this for y'all? Their solution seems like way overkill to me here, because we know that they're only ever going to provide 2 cards. That was kind of given to us as a constraint. So they're iterating over 2 cards all the time and then doing a comparison. So the way this is implemented is like they could do a can split based on an arbitrary number of cards, but that's not the constraint and the rules of Blackjack in this case. So I think this is like I read this as a way overkill solution, but a clever one nonetheless. And the bounds that they did for their can double down stuff is they have 8 and 12 because they didn't use the equality like I did. Otherwise, it's the same thing. Again, though, with this weirdness of like, they're really into iterating over a list of cards. That's odd to me. Anyway, cool stuff. Good job. Wengel. Let's go with Wengel. All right. Scan through. This is just I think this value of card is just kind of shuffling around where the if statement goes. This could be unpacked in the same way, and they're using the inline if-else construction here to do the same thing, but really that's not that different. Interesting, they're not using an early return here. I would use an early return instead of that style, but to each their own. Okay, so this is, don't do this. There's no need for those parentheses there. It's just a string. So like the parentheses around this is confusing. It might lead somebody to think it's a tuple, and it's not. It's just an extra set of parentheses. So it's really, I think this is the kind of code that would be flagged by some linters as saying like, you don't need this, or Black would just take that out. I'm pretty sure. It's not doing anything. Total score. Oh, that's interesting. They throw in an extra 11. And they're looking for 21 values there. Okay. Interesting approach. And the final 2. Oh, okay. They're now, so whereas I was checking for a range, are you within the range? They're literally looking for one of the 3 values that is allowed, 9, 10, or 11. Okay, cool. Ciro Fabian Bermudez? Good job. All right. Let's do one more. I know I brought up 4. Sorry to be Haggerty, but we're only going to look at one more. I like this version with the string thing. That was what we saw in the first version. We've got a little bit of parenthesis obsession here. This person may be coming from a C language. Yeah. In Python, you don't need these extra parens. So that's really not needed. Oh, wait. What are they doing? Something clever here. If it's an A or an A, Return 1. Oh, okay. I see what they did. Because you can't have... It couldn't... If one of them's an ace, it's already an 11. You can't have 2 aces. Although that gets back to my question of like, could then the ace stand for something less than 11? I'm not really going to dig into that too much. All right. I think we've had enough. So I'm going to go... that's the blackjack problem. Let's go back and submit to my solution. Or you can go to the overview and mark it as complete. And the next time we can do another one. Hopefully these are kind of entertaining at least. I don't know if you all are picking up on stuff here. If they're boring as all get out, let me know. I don't want these things to be boring. I just find this stuff kind of interesting to see how other people are doing it and test my brain a little bit as well. So we are done with Exercism for the day. Let's look at some SaaS stuff and see where we're at. I still don't have like a project that I want to be working on for my SaaS project. So I think what I want to do is continue going down the list here and look at a bug. Okay. So let's look at this one. The teacher checklist. So as a context, if you've never been on the stream as I'm doing the SaaS part of this, is I work on a homeschooling app. This is a homeschooling app helps my family. My kids are homeschooled. My wife is the teacher. And this is a feature that was actually not requested by my wife. It was for a checklist to allow a teacher to see all of the activities for a week. And it was a view that I built in Django, but it has a bug in it. So let's take a look at the bug. So it says the teacher checklist does not show the school year on the first week. All right, and then I gave myself an example here. So the school year had an 8/15 start date. And in my app, which is called School Desk, all of the weeks are assumed to start on Sunday. I just did that. Like, I've seen apps that offer a configuration of like, do you want your week to be counted from Monday and have Monday through Sunday? Or do you want it to be on any arbitrary day? And to simplify the problem, because a lot of the value proposition and what I'm trying to sell with the product is that is simplicity and low configuration, is just assume that the standard week that we're going to operate on is Sunday to Saturday. So a lot of that helped me a lot, frankly, with a lot of my scheduling calculation that goes into the application, because it's all about building a schedule for a school year to help drive what the students need to work on week to week. I guess I should have led with that. That's the core of what the product does. All right, so this school year has a start date of 8/15, but Sunday was an 8/14. I anchor all my calculation looking at what's the start of a week, and I look for a week. So because of that, no school year was found, even though there's a school year later in the week, and this is an edge case. It's a pretty rare thing to have happen, but as I think about like somebody who's trying to use the product for the first time, and they might be looking at what is this teacher checklist, and then for it to not to be there on their first week is a real head scratcher. So it is an edge case, but it is an edge case that I think people are likely to hit as they're trying to use the product and for the first go of it. And so I think that's why it's important to get it fixed. Let's move out of this code area and look at, I got to remember where this is. So I think I made it a new teacher's app for this. And we have a view over here, which is the checklist. Now, the question becomes, how do we extend this to get the right week and such? Let me first orient you, dear viewer, as to what I'm doing. Let's start at the web server, and then I'll show you the feature itself. Because I know I spoke through it, but sometimes that's not enough to get really good context of what's going on. So we're going to go to port 5000, which is where my application runs. And we're going to log in, and I'm going to stumble through what the login credentials are. I think it's Oh man. This one? Firefox is telling me that I have this. Oh, good. No, LastPass, not now. Don't need to remember this for my local host. Thank you, that's useless. So here we are, and this is what a week looks like in the app. Now, a full user experience of this has typically, way more subjects that you need to cover. Like, I've got 2 students that are here just for the demonstration purposes, but in a given year, school year, you might be running like 10 courses or something to that effect over a set of semesters. So even though this page is abbreviated, you can view it, you can kind of picture it in your head as like something that will go longer. So what we do with the checklist is we have this other option that then gives this something that is ideally printable by the parent or the guardian, whoever's teaching the child, and essentially takes the whole table that was there and kind of just linearizes it so they can add notes to the side and such. That was sort of the requested feature by the user who was asking for this. So here's what we have, and I think maybe we can synthesize. I'm trying to think if we can quickly like just demonstrate this in failing, or if that's even useful. Because I don't think it's truly useful. I think we could probably write a failing test that that would prove that this scenario happens, and then that's probably sufficient. So just know that in your mind, when this would be the first week of the school year, if the school year starts midweek, it will not show any data here. This would be a blank page. That's the behavior that was seen. So let's go write our test and see if we can demonstrate that through the context of what's going on. And the spoiler alert, the problem is right here. It looks for a school year based on the weekday, and the first weekday that it starts with is the Sunday, which is outside the range. So we need to be able to like modify the weekday or look for a slightly different weekday if we didn't get a result. So there's going to be like maybe an extra clause here. I'm not really sure. I gotta figure out what I want to do with that. But we can write the test first, prove that it's not right, and then back into the solution as we think through that. So let's open up the teacher's test views file, which is up here. And so we've got our checklist. And so I want to write a new test and say, I want to call it something meaningful because this is like a bug condition that I want to remember, and say test school year start midweek. And we'll say a school year that starts midweek will still show a checklist. Yeah, thanks, John. I think taking this approach, using some TDD in this style, especially for a bug, that's what I love about, well, frankly, about computers. And assuming you're not doing like crazy parallelism, a lot of the problems that you can solve on a day-to-day basis with most work is very deterministic, which means that if you can write an automated test in a deterministic way to prove that something is failing, and then you make the test pass, you can have a very high degree of confidence that you actually fixed the thing. So it's really about crafting that test. So what we want to find is we want to get a result that's actually going to have a schedule. Like right now, you can see that, well, it has the schedule's key, but we want to actually check that the schedule has some data in it. And I guess it's been a while since I've run these tests, and so I want to probably mirror a setup like what we see here, but then check that the data is there. So let's do that first. So I'm going to throw in an assert false guaranteeing that the test will fail. And then I want to print out the context. The reason I throw in the assert false is that Python, if you have a passing test, Python just won't show you standard output, which is kind of annoying. So that's why I do that. So we say self get context, and then we say schedules is the thing that we're looking for in the context, and I want to confirm that there's actually data in there. Why? Do not call. Okay. Come on, Python, shut up. Do not call assert false since Python removes these. Yeah, I know. Oh, it's an empty list. Okay, so that's not good enough. Like we need a schedule that actually has some content in it, and it actually makes me doubt. Well, this test is like really just proving can anything run, which is not cool. Okay. Well, let's take this test. Let's add a little data to it till we get something else, and then we can back into the test scenario that we're actually trying to prove out. So we'll delete those 2 lines. We'll work on our test here. Wow. Interesting. Remove. So, sorry, I'm getting distracted by, I've never had spam chat like that before in my chat. Good times. Not really. Is this a case for a fixture? John, I have mixed feelings about fixtures in PyTest, and I think there's also, there's some other stuff that I don't really highlight typically, but because I'm using the test case class, PyTest fixtures do not actually play super well with the classic unit test cases. And this test case that I've got defined here, which we can see, well, homeschool test, I just had it there. We can see it here, is deriving from the plus test case. So this is from this test plus package. If you trace that back, it's deriving from the Django test case. And if you go back, it's all the way back to the unit Python standard library unit test case. And that class, being as old as it is, has some history of why it doesn't play super nice with fixtures. So I'm going to punt on the whole fixture issue right now. There might be some like cleanup worth doing later, but I'm going to not bother with that. I'm going to try and stay focused on adding some content here. So we have a school year, and what do we need? We need something in the schedule, which I think means we should have at minimum a course task. That feels right. Let me check against. There's something in this thing that's using this get schedules function, which is a very complex function that I'm not going to go into. It gets used by the core as well. One of the main views that I have. So the test for the core should also have some interesting data. So if we look at that, we can find what data we might need. And we want to look at the dashboard. Because in order to get a schedule, we have to do more than just have a school year. We have to have a student enrolled, and that student has to have some kind of grade level and a course, and like all of that stuff like goes into building this up. That's the challenge with my data model, is that it all kind of hangs together in terms of a big tree, which means when you get down to the leaves of it, building up the right structure for each test can prove to be a little difficult. And the factories do a lot to mitigate that, but they aren't perfect. So I think I need an enrollment factory example. And we're going to want to have a student enrolled and then a task. And having those two those two conditions being true will make it so that there's content that would appear on the checklist, is my belief. You don't know my data model. If you haven't joined me before, don't worry about it. Just know that we need a couple of database entries in order to make this work. So I'm going to steal. I guess I'm going to steal all of this. No. Yeah, all of it for now. And we'll drop it in here. And we'll change this. There's only going to be one grade level. And we need a school year now. Or we need to store the value. And we need to have that be the right name. I don't know that we actually need to keep the enrollment and use it in any way. We just need for one to exist. And then we need to import these things. So the enrollment factory comes from students app. Let's do from homeschool students tests factories import enrollment factory. That's that one. And then the grade level factory comes from the schools app. That would go here, grade level factory. All right. I don't think that's going to be enough. I think if we run this, it's still going to show an empty schedule. Okay, no, I'm wrong. Okay, we have no courses, so you can see the data that's in here, but I think that might be enough. Because what was going to be in here, what we're trying to prove is that there's something in the schedule. Because if we look at this, schedules is going to be an empty list if there's no school year. But it would be populated if there is a school year, and then they can get some schedule out of that. So that's the critical element. So proof that our test will work will be that there's something still in the schedule after we adjust this. So I want to say we want to say assert self get context for schedules is not, well, I don't know that I want that. That could work, but an empty list is already falsy. So we would just want to, actually, I think the simpler thing is just assert that it's there and it has a value. Like, so there's a difference between these two lines. The first one is asserting that the key is even in the context. The second one here is getting the schedules themselves and the value of it, and then doing an assertion on that. And if it was an empty list, it's going to say return falsy, and so the assertion will be false. But if it's not an empty list, as we just saw when we printed that out, it would pass. So I think what's going to happen is if I get rid of this stuff, this test should pass. And it does. Now, and then let's prove to ourselves that that it won't pass in this case, because here it's an empty list. All right, so I think we've set up the conditions that prove that the output to assert on is correct. But what we haven't done is set a set of dates that correspond to the bug that we're trying to simulate. So we need to essentially look for a Sunday and then create a school year that is a little after that. So this is looking at June 15th, 2022, no doubt when I wrote this test. I have no idea what that corresponds to anymore, and I'm too lazy to look all the way back. So we're going to modify our dates. Wow, that is not what I wanted to bring up. Not calendar. Oh, that is calendar. I've never seen it have that menu kind of before. So here we are on November 30th, 2022. And so I think the scenario that would reflect this is to say, let's set this to look for the Sunday, which is the 27th. But let's start the school year on, say, well, I guess it could be Monday. It doesn't matter. I'll use Monday because that was my birthday. How about that? So we want the week to be 2022, 11/27. That's the start date. And then here's where I'm going to create the school year to be 1 day later. And at that point, I think this test will fail. So if we say first day, thanks, John. Yeah, 39 laps around the sun. Getting older. So I want to just adjust it just by 1. That's all that we need to really get it passed so that it doesn't match up. We want to do date, time delta, and then we can do days, days equal 1. And I think this is now going to cover that case. So if that's to be believed, then this thing should now show up as an empty list. Cool. All right, we got it. So now we have our tests that I'm pretty confident that if we can make this test pass, then we will have fixed the bug that we're trying to fix. Let's go close this. I want to leave this test up in case we need to modify it, but for the purposes of, I don't know, my eyes are naturally going a little bit more on this side, so I'm going to rotate the test in the code file. All right, so what do we need to do? What do we need to do? I know that the way that this is called, we go back to our page. Let me see. Can you all see my? I think you can see my URL bar, which should show in the corner. It shows 2022 11/27, and then it even tells you right here: Sunday, November 27th, to Saturday, December 3rd. Okay. So my code on the page that showed this, actually it's still running in the background. So we can go back, and here we've got this page. This URL is always configured to go to the checklist page based on a date and anchoring towards that first day of the week, which is why we have these 3 parameters here. If I were to go to the url.py file, you would see that those are required in order to actually generate that URL. So the URL in the template expects all of those 3 parameters to exist. Otherwise, it will fail with a, I don't remember the specific Django error, like a no URL resolved. I don't know. I don't remember what the error is called anymore. Doesn't really matter. So what that means is we have it on that Sunday, but we have to be able to do the look ahead to see, could it be this day or any day between here and the next Sunday. I think that's the reality. So there's a couple of ways that I could approach this. One way would be to modify get year 4 and have it do the looking ahead and try and catch this boundary condition. I am fearful, though, that having that that fuzziness about what it's going to select is going to cause problems in other parts of the app. So I think what I'm going to do is try to guard for this case in here, like one line below, and say, if we didn't get a school year, let's do a second attempt and look for school years that would have fallen, this plus 6 days. Actually, that might be the case. That might be the scenario. The most likely scenario is, since it looks by a date, if I can find a school year that is on the Saturday following the Sunday, full 1 week out. If there's any school year in that range, then we'll know for certain that something that needs to be displayed for that week for that checklist should be there. So I think that's like the second attempt. It feels that solution is sensible and it makes sense with the domain. I'm trying to think if it feels too much like a hack or if there's a more general way to solve the problem. Something about it feels a little off of doing a second query if it wasn't there. But maybe it's the right approach. Maybe it's just what you have to do. So let me read your comment there, John. The error only happens in the first week on a day that is not a Sunday, right? And you just test for week 1. The nice part, so this is actually, the important part of this is it's looking at all school years for this user. So we can't look for a specific school year. We have to look at like the way the app is designed, the model is that a school year has a start and an end date, and 2 school years cannot overlap. I've made them mutually exclusive on their range. We can't test against a week 1 because it has to, like, it could be at any point in time on the user's entire history. So it's looking at that whole table. So really what I'm trying to do is like, I've got a school year that's in this range and we're just out here right now. And I need to like nudge the starting date to be fit in that box, if that makes sense. Which is why I'm looking for, can I, if a week's only ever going to have, that's the nice part. The week is fixed to 7 days, thankfully. We're still on Earth and yeah, like avoid the whole calendar discussion. So looking ahead, just a few days, I think, could be the way to like do that check and see did it fit? Did we find one as a second chance? That's the only way I can think to do it in like a reasonable number of queries. Yeah. All right. So I'm going to go with that approach for now, and I think it'll solve the problem. And then I'll be happy and move on. So let's put a comment in here because we're going to do something that's going to look a little weird. So check for the first week boundary condition. And I think it's helpful to, some people in some language communities have this philosophy of comments are bad or comments are a code smell, and they can be, but I think that there are cases like this of there's reasons that code accrues over time, and it's usually because bugs found in an application or some domain model that doesn't make sense. And I think in those scenarios, I'd rather be over expressive of why am I doing something, especially if I come to this code later and be like, what is this? Why are you checking for school year again? Then you have an if guard just 2 lines down that checks for it again. That doesn't make any sense. Without a good comment, there would not be enough to signal to me as a future reader that, hey, there was a reason for this. It's not just arbitrary. And then it would convince me to keep the code. Even if I was like didn't comment it, thankfully I have a backup. And that backup is I have this test now. So if let's say I didn't put this comment and I just added the code that fixes the problem, and then I come through in the future and like, this looks stupid, what's this for? And deleted it, I'd run my test suite, and my test suite would say, no, there's a reason why this is here. But I still like the story to remind myself of this is what this was for. So we'll say check for the first week boundary condition to look for a school year that may have started midweek. Okay. So we're going to say if school year is none. That's this case that can come back. That's what this guy can return. Should come up in a second here. Yeah, you can see optionally it returns either school year or none. It's got an optional return. So we want to do another query, and it's going to be the same thing, But looking to the Saturday. And I'll put that very explicitly. Look ahead to the Saturday. If we don't find it, then no big deal. So we want to add date, time, time delta, days equal 6, right? Should check that math. That this is going to return the right date. I'm actually going to be paranoid about that. I mean, it seems so obvious, but you know, stuff happens. Stuff gets weird. And just so we can see that printout, because I think this test might actually pass now. Oh, it didn't. So what? Oh. I've got everything still anchored in June. Or on this thing. That's not right. Let's change that to 11. Now I'm doubting if I had the test conditions right. All right. So 12/3. Did I get it right? 12/3. There's the Saturday. All right, the math is right. Can delete that print. And I think, are we good? Test passes. I'm going to come back through here, and just like I had earlier, I'm going to make sure there is a schedule. Yep. All right. So I kind of messed up the test there a little bit, but I think I recovered. Okay, I think this does it. Now, there's some assumptions that are built in here, but I am the author of this app, and I get to control all these variables. But I'll be explicit about what these assumptions are. The way I've designed this is to assume that the year, month, and day is always a Sunday. In fact, why don't we document that? In the very unlikely universe that I ever sell this app to someone else in the future, if I maybe stop homeschooling and don't have any need to do this, might be nice to know what's happening. Or it might just be nice for future me from 4 years from now who's still working on the app and is like, what's going on? So let's say this view assumes that the date provided is a Sunday at the beginning of the week. All right, cool. I think we're done. I'm not going to go through the test scenario to prove this. I am sufficiently convinced that our unit test does do that. So to end this, and probably to end the stream for this evening, we will check this diff out really quickly. So we've got one unit test, and ultimately that was, we had to write 2 new lines of code, but it was the thinking that got us there. We actually spent more of the time thinking through the test and what was actually required than the actual change. It's kind of like, I don't know if you've ever heard this kind of comparison, but let's say you have a washing machine at your home, and something is wrong with it, and you don't know how to fix it. And so you call a repair guy, and he comes to your house, and he gets in there and fixes it in 5 minutes based on hearing some noises in the washing machine. And you're wondering, like, why did I just pay you, a couple $100 or whatever it will turn out to be? And the reality is, like, it's his experience knowing what that noise is that you're paying for. It's not the fact that he did it in 5 minutes. That's not the value. So similarly here, it's like, it's not the amount of code that we wrote. That's not the impressive part. It's the fact that we were able to reason about it and get to that solution. All right, so let's check that we still have 100% coverage. I'm convinced we do. We tested that exhaustively. Cool. And let's commit it. I've got some new pre-commit stuff. So this will take a second. And we'll say fix boundary condition for new school year on the checklist view. And this fixes number, what was it, 700? Man, getting some big numbers there. 700, okay. Push that up. Cool, another one bites the dust. I don't want to get into this next issue, but we'll talk through a little bit about what this is. So next time, I should be around next week, so we'll have another, ideally have another stream. I'm not running the Python meetup, so we'll have a stream next week, and we'll go through another Python exercism exercise. Hopefully there'll be a little bit more variety in them as we get beyond the basics. But when we get back to this issue list, this is going to be an interesting one to tackle. We're going to look at this particular problem. I have a subscriptions page, and the way you sign up for the app is you go through Stripe, and I lead to a Stripe page. There's a jumping off point of you're in the homeschool app, and you click some buttons, and it takes you to Stripe, and it gives you their experience for doing the sign up. And I've been able to, as a user, go in and customize and add some branding so that someone who's visiting my page knows that it's actually my stuff and not some other random vendor that they're paying. And then it brings me back to my site. That's the flow. You can go read on the documentation of how Stripe does that. The other day, well, this is no longer the other day. This is back in July. Good grief, time flies. I was looking at this problem, and I saw something on my subscriptions page when I had the JavaScript console up, and I was seeing some sort of stuff that looked like errors. And I need to dig into this and figure out, is this a problem? Like, could be that I've had people signing up and my subscription page is not working. That would be bad. I don't think that's the case. I think I poked on it to kind of confirm that it's going on, but I still want to figure out what's going on here. So if you're not aware, there is something in web browsers called the content CSPs, the content security policy. And it is a scheme it's a security mechanism. You can read here. You can probably just read it out to you. It adds a layer of security that helps detect and mitigate certain types of attacks, including cross-site scripting and data injection attacks. Essentially, it's browser protections that are there on third-party JavaScript, third-party requests that are on your page. And I saw some CSP kind of error-looking stuff on my page, and I want to make sure, since this is on my subscription page, that I don't actually have a problem. And if I do, I want to figure out how do I make those problems go away, because I'd rather have the peace of mind knowing that I've got my security configured correctly, especially when I'm doing something as sensitive as talking to a payment gateway vendor like Stripe. So that is the page that we'll go over next time. I might have to do some configuration there because it has been something that I've not actually configured my local environment to use my Stripe test keys. I might need to do some setup there. So there might be some secrets that I have to mess with in the meantime, but this is the plan. We'll go over that. So hopefully that was informative to you. John, thanks for joining in. Sorry you're sick. Hopefully you're feeling better soon. And I will see you all next time. If you can, leave me a like or a subscribe or a comment. If you have comments, I'm happy to answer your questions on these videos that get posted. If you want to check out other videos, I've got all of the streams from way back when I started this project a couple of years ago. You can go check those out. I'm also starting another set of streams to specifically go over exorcism exercises. So the ones that we don't do on stream here today, kind of like packaging them up into their own dedicated video. And there's no banter back and forth with people, but I do walk through the problem as I've seen it and propose a solution. So if you're looking to learn some more Python, keep your eye out for those. Again, thank you for joining in. It's a good discussion, and have a nice evening. Take care.